Thank you very much. So, hello everyone. Today I'm going to talk about OSTrICa, which is an open source threat intelligence collector. So, that's the agenda. I'm going to do a very quick introduction to threat intelligence. I'm going to show you a few scenarios where threat intelligence can be used. I'm going to explain what is OSTrICa. I'm going to show you a demo. Hopefully it's going to work. And I'm going to show you how to develop OSTrICa plugins. Who am I? I'm a senior anti-malware engineer at Symantec in Dublin. Normally I work as an independent security researcher doing some, development of tools, malware analysis. And time ago I worked as a security consultant. I was doing mainly incident response and penetration testing. Those are my contacts and my GitHub page where I will upload OSTrICa. And you can find some of the tools I developed and some of my research. So let's start off with a brief introduction about the big problem that lots of companies are having. Data breaches is a very, very big issue for everyone, for the company, because as you can see from this very nice graph, from 2012 up until now, there has been lots of data breaches, eBay, Anthem, even Adult Frame Finder, Ashley Madison, Hacking Team, the Italian company that developed the Galileo malware. And the main problem is that when they get breached, lots of information are stolen and released to the public. Even the source code of this malware, that Galileo malware that has been used, basically they copied and pasted some of the code in the malware. And that's a very big problem for the companies because they're losing their data, they're losing their money. But even for us as a customers, is a very, very, very big issue for us because if they steal credit card information, email, physical addresses, that's a very big problem even for us as a customers. And well, for the companies, of course, they lose lots of money. All right, so at the moment we are using different things to protect our network. AVs, firewall, IDS, whatever. They work okay, but I think that another thing that should be implemented in our network is threat intelligence. And according to Gartner, threat intelligence is basically the information, including context, mechanism, indicators about a specific, threat, a new threat or even an old threat. And with this information, if you can link them together, you can actually profile the threat and you can try to proactively protect your network. What can you do with threat intelligence? So you can do attack investigations, so you can track down cyber criminals. You can provide a context to reconstruct the attack quickly. So if you are an incident responder, you can use threat intelligence to identify new domains that the malware can use, or the IPs, or any file that has been created by the malware. You can proactively block new attacks, and of course, you can prioritize specific alerts in your systems. And if you can provide these alerts, these alerts to your C-levels, they might be able to make business decisions. Like, for example, they can invest money for training, they can invest money for new products, and so on. So let's have a look at a few scenarios on where we can actually use threat intelligence. So the current solution that most companies are using are the AVs, the firewall, IDS, log collectors, whatever. They works fine, but this is actually just data. We can create AV signatures, we can do everything we want with that, but let's suppose that we have our internal data and we can also grab external data from external sources. So if we can merge together the information, if we can link together the information, that's what threat intelligence is. You can, for example, identify the attack, for example, a PDF. From there, you link together the information and you can identify where it came from. For example, a phishing email. From there, you can identify the victims. And so on, you can identify, for example, the kind of data that has been stolen from the victims. And sometimes you can even, with the help of law enforcement, identify the attackers behind it. But not only that, you can even identify the attacker infrastructure, because you can see the servers they are using, you can see what kind of network they're using, you can see lots of interesting things, and some of their server might be kind of vulnerable. So you can identify additional information, like information stolen. You can identify interesting data about a specific gang behind a specific attack. Another thing is that threat intelligence can be used to proactively protect your network. What does it mean? Let's suppose that we have one machine in our corporate environment. It has been breached, and we see from our logs that is connecting to a specific server in US, sending data. We have another server in South America, and still is sending data. So we have this information. Let's suppose that the same exact behavior is related to some external sources. So let's say on VT. On VT, we find out that this specific behavior is associated with another, let's say, behavior where the server located in Russia is basically pushing an update to that specific machine that has been compromised. So if we have this information, we can proactively protect our corporate network by, for example, we can add a firewall rule to block a specific update. That's the main thing about threat intelligence. It's very, very powerful. The main problem is that you need to link together lots of information. And where can you get this information from? For example, if you are talking about indicators of compromise, we can talk about MD5s, for example. We can talk about the domains, and we can talk about the IP addresses, the AV detections, the mutex names, the file names, and so on. So we can grab this information from different sources, like free sources, where they are actually, of course, free. They contain generic information. They come from public systems or honeypots. We have the community systems, where they contain generic and some of them specific intelligence information from, for example, sandboxing products. Sometimes they are free, sometimes you need to pay a little fee to get access to this kind of feeds. And the commercial one, which are very, very expensive, talking about thousands of dollars, even millions of dollars, but they have a very specific intelligence. They can basically give you information about a specific threat actor. They do surveys, they analyze underground marketplaces. And of course, that's the main problem. It's very, very, very expensive. And the other thing is the internal one, like our appliances, log collectors, firewalls, AVs, everything. And it's a very, very specific intelligence related to our network. It's free, of course. So what if we can actually grab this information from everywhere? So, I mean, internal, commercial community, and free sources. That's the end goal of the tool that I developed, that I'm going to release it on my GitHub page. It's called OSTrICa. So what is OSTrICa? OSTrICa is a plugin-based system where you have a plugin loader which loads every single plugin that you have. You can create any plugin you want. It loads the plugin, it executes the stuff I'm going to show you later, and then it can visualize the information. So for example, we have an MD5. We found out an MD5 in our network. Okay, we give it to OSTrICa. That's basically the structure of my tool. See, there is VirusTotal. DeepVits is an Italian company that developed some sort of online sandboxing system. We have safe browsing, Whois, and many others. You can develop any kind of plugin you want to collect the data. So in this case, we say, okay, OSTrICa, what do you know about my MD5? You say, okay, that's the MD5, and then the MD5 goes through all the plugins. So if the plugins can collect information about an MD5, it will be executed, and it will start collecting the information, and then it can show the information to you. For example, in this case, VirusTotal can handle, for example, MD5 and SHA-256, and DeepVits can handle MD5. So both of these two plugins will be executed, but safe browsing and the Whois, they don't know anything about MD5, so they basically do nothing. So for example, if we have a domain, we give the domain to OSTrICa, and VirusTotal will be executed, DeepVits will not. Safe browsing will be executed, and the Whois will not be executed. How does it work? At the moment, the tool has been developed basically in my free time at home when I had some spare time. So I didn't want to pay a single euro for accessing specific services like VirusTotal or any other services that I'm currently using. So most of the plugins are using web scraping techniques where I scrape the web page, extract the information, and I collect the information. Only one plugin is using API, which is DeepVits, because it was free. So I basically implemented the API access to DeepVits. Once the plugin is executed, they will produce a JSON report where the analysts can actually look into it and see all the information collected, and a visualization module which creates a visual report. And only some information are actually shown because I'm collecting loads of information and only some of them I'm showing. And so let's move here. Why OSTrICa? Well, first of all, because it's free. It's open source. I'm going to release it soon. I need to fix some stuff. The code, of course, has not been reviewed by anyone, so it'll probably be full of bugs and whatever. It has a plugin architecture, so you can fork the project, you can create your own plugin, and you can use it basically for free. It can actually proactively, well, it cannot at the moment, but threat intelligence can be used to proactively protect your network. So if you write some code, maybe you can identify how to proactively protect the company's information by adding specific rules. And then, of course, as I said before, it produces a JSON format, JSON report containing all the information, and then a visual report which can be used by the SOC analysts inside a SOC. They can be used by incident responders to identify very quickly what's going on based on specific indicators of compromise, and then can be used by attack investigators when you have to investigate a specific attack or identify specific information behind a specific attack. So, quick information, all the collected information are taken from open source sources, so they are available. I haven't used any semantic internal data, of course. You can do that if you want in your network, but for this demo, the information are taken only from external sources. So I'm going to show you a demo now on how it works. So let's see here. That's the directory structure of OSTrICa. That's the main executable. It's written in Python. There is a report directory which contains the JSON output of the collected intelligence, and there is a visual report which contains the HTML files. Thanks. All right. Okay. So, to run OSTrICa, you just need to, well, there is a command line interface, which is this one. At the moment, you see no module, no module named BS4, whatever, because lots of plugins, as I said before, they are using web scraping. I'm using Beautiful Soup to scrape the web pages. And I installed a different other libraries like DeepFit Sandbox and Whois. You don't have them here because I didn't develop all the stuff on my machine, on my production machine. But yeah, how does it work? You have a help here. I don't know if you can see it. Basically, you can provide different intelligence information like the IP, the MD5, the domain, SHA-256, ASN, email, and then you can basically you do something like, let's suppose we have something like this. Now we have this one. Let's suppose that this domain has been seen by our firewall logs. We do something like domain equal to this. Automatically, OSTrICa knows that this is a specific domain. So if you do run, I'm not running it right now because I am not connected to the internet and I don't have the libraries to collect the information. But basically, if you do run, it will generate a report in the report directory, like this one, for example. Oops, not him. Now, so this is the JSON report that the analyst can look through it, so it can see what kind of information is being collected. Let's see, page down. Okay, blah, blah, blah. Now, so for example, in this case, the requested intelligence was an MD5. The plugin that has been executed is DeepFit. So if you scroll up, you see all the information about this specific MD5, the connections, the UDP connections, which, well, the DNS lookups. If the DNS has a specific IP related to it, it shows you the IP. And the cool thing is that you're not actually executing the malware. You are relying on an external source to provide this information, so you're not doing anything on your network. Exception made to querying specific remote services like deepfeeds. In this case, I was using VirusTotal. See, because all the information here are related to specific detections. So the AV result is the AV name, the detection name, and when it was updated. So you see all the information that you can actually go through it, and then you can identify if there is some additional data that you want to extract or collect using OSTrICa. And you have all the information about the behavioral information, if there is. And the main problem is, as I said before, I'm not using APIs, so I'm scraping the web page. At the moment, VT, they probably found it out because I run lots of queries for testing. They didn't block me, I don't know why, but still, it's working quite okay. The main problem with web scraping is that if someone changes the pages, of course, you have the output will not be like this, will be something, I don't know, something weird, because they changed the page, so they changed maybe some HTML tags and so on. Now, the cool part is, so going back to this domain, so let's suppose that we run our tool. If we do something like graph, it automatically generates a graph based on the information that it has collected previously, because first of all, you need to provide the intelligence, then you need to run the run command, and then you need to generate the graph with graph, of course. Where are the graphs? Are inside the VITs directory. So let's remove this one. In this case, for example, should be this one. I hope so. Yeah. Oops, sorry. It's this one. So see, we have the domain, and then we have the information collected from the different plugins. Like, for example, we have here the IP related to this domain. We have the URL, and then we have the email that has been used to register this specific domain. So OSTrICa will also can identify if a specific email has been used to register other domains. So you can provide that specific intelligence to OSTrICa as well. And then you have other TDL information. The colors here are actually related to the legend we have here. So the original intelligence, which is a bigger node, is this one. And then you have VirusTotal, which is the IP address because it's been detected by VT. So I'm collecting this information, and the domain that has been detected by VT. Then in this case, we have domain big data, which is another external sources I'm using. And you see all the related information to this domain. TCP IP utils, no information back from it, same for the others. Let's move to the second part here. So let's suppose that we found out this information from our network appliances. Now we see, okay, I want to know something about this MD5 because it connected to this IP, which is actually related to this original intelligence. So we do something like this, copy, and we do something like MD5. Okay, and then we do IP equal to, oops. So if we run the tool again, I'm not running it, but then if it start collecting the information, so it's going to take a little bit of time because depending how long it takes to the server to reply back. And then if we do graph again, the previous graph is overwritten, and the output is something like this. It's kind of messy, but you can zoom in, you can move the nodes wherever you want, and you can, for example, let's suppose we want to know something about this specific thing here, which is URL. We click on that. Every other node are hidden now, and you can see exactly if that specific node is related to something. In this case, it's related to, I suppose, the IP address. Let's see. Yeah, so because basically, you see here, that domain is a detected domain by VT, and is related to this IP address. Another cool thing is that, for example, if you double-click on one node, it will automatically disappear because, okay, we say it's connected only to our IP. I don't want this information because it's just one link. I don't need this information. We can hide that node. We can double-click on that, and it basically go away. Another very interesting thing here is that I'm going to show you with this other thing here, which is actually, let me see. So these are three different MD5s. And if we click on one node, like this one, for example, that's a mutex. See, I suppose you can see it's a mutex, and all of them are sharing the same mutex. Although this mutex is kind of generic, so you cannot really base your detection on this mutex, but it tells something. So if you try to double-click on this, it says, okay, so you're trying to remove a node that is actually related to an original intelligence that you provided. Are you sure about that? Because maybe you're gonna lose the links that I created for you. So you can decide to remove it or not remove it. And another thing is that the graph is quite noisy because I'm collecting loads of information from everywhere. So if you add other, let's say, 10 plugins, the graph will be huge. So you can, for example, search for information like, I don't know, Trojan CryptoLockers. It automatically identifies the nodes related to CryptoLocker, and it hides everything else, and it shows you only the CryptoLocker node. So you can see the relation between the different nodes. Or you can, for example, does it work? Hide specific information like VT information, or you can remove or hide all the deep widths related information, and you can show them again. That's the cool thing about this graph, because you can filter out nodes that you don't really want to see. Same for the other plugins. You can hide the mutex names, or you can hide the domains, and things like that. So at this point, there is another thing that I implemented, like, for example, see the node is kind of bigger if you compare it with this one, because if you click on this, you see that it's related to multiple other nodes. So you see, okay, it's getting bigger because this information maybe can be useful for you, because there are lots of other nodes that are in relation to this kind of IP address. And of course, you can, oops, does it work? If you double click on one original intelligence, it will automatically remove all the nodes that are not associated with other original intelligence. So you are removing all the nodes that are not associated with your original intelligence. In this case, it's still kind of noisy, but let's, for example, remove deep widths. So what do we have here? We have, we have 3 specific original intelligence. 2 of them are detected as cryptolocker.n. One of them is actually not detected at all, but it is sharing the same mutex name. As I said before, this is kind of a very generic mutex name, but it's sharing an IP with another node that has been detected, and is sharing the same probably command and control server HTTP request. So you can go back to this one and say, okay, this is not connected. Well, this is not detected, but it's actually connected to other nodes that are detected, other malwares that are detected. So at this point, you can, for example, send the file to the AV company so that they can detect it, or you can add your own rule to remove it. So that's how you can proactively protect your network, because you didn't, it was not detected. Oops, where is my mouse? It was not detected, but has some relation with other nodes that are actually detected. Okay, so that's the demo. Now, I'm going to show you very quickly how to develop the plugins. The plugins are inside, I suppose here, yeah, OSTrICa plugins. For example, these are all the plugins that I'm currently using. All of them I'm scraping the web page, exception made for this one. Let's take safe browsing. You just need to open it. Okay, it looks kind of complicated. It's even difficult to explain. Sorry. But you need to basically get the code to understand how it works. I'm going to show you very quickly, but it's not that complicated. So the first thing is that you need a specific function that OSTrICa is calling from outside the plugin, which is run. In this case, run will execute specific functions inside the main class, which is this one. And what does it do? Basically, I'm just collecting the information from safe browsing, providing specific user agents and things like that. The easy thing is that in this case, the response from the server is a JSON format, so I don't need to parse it. So it's going to be very, very easy to add the JSON output to the report. You have some information that you need to specify, like this one, the extraction type. So are all the types that specific plugins can handle, like the IP, like the domain, or like the ASN number. And well, you have this, which means, okay, do you have any visual data that you can represent, that you can show to the user? Yes, because there is a class that does that, and if it's enabled or not. In this case, once you collect all the information, you just need to send them back to OSTrICa. The structure of the data that is sent back is a sort of a dictionary format, where you say, okay, the extraction type is, for example, domain. And the intelligence information is all the intelligence that you collected through the plugin. Then you have the data visualization, which checks if the plugin is actually the one that I'm currently using. There is another class here, which is a safe browsing visual. You pass the nodes and the edges and the JSON data that you collected from here. So that thing is done automatically by OSTrICa. So when you run graph, this function is called and executed. And okay, this class will basically, it's kind of complicated to explain here, but if you take a look at the code, it's kind of easy. You just pass the original output that you got from here, and you say, okay, do I need this information? Do I need this information? Yes or no, and then you decide if you want to process it or not. Eventually, I am processing the domains. So all the domains that I collected from safe browsing, I'm passing through each of them. If a node is already inside, if a domain is already inside our node dictionary, I'm just increasing the size. That's the color of the node, which is the one that I showed you in the legend before. And then that's the type of the information that has been collected. In this case is detected domain. And then, of course, you need to add the edges because if the domain is not in the edges already, so it's not connected to the original intelligence, you need to add that, otherwise you won't see the arrow pointing to it from the original nodes to the collected node. Yes, I think that's, yes, that's it. So the main problem, as I said before, is that some plugins are using web scraping. So if you have, for example, the VT API key, which I don't have, at least personally I don't have it. So you can modify the VT class, which is quite huge because I'm passing every single thing in VT, like the detection name, the mutex names, the behavioral information, file names, when the file has been seen, and things like that. So you can add your API, and of course you need probably to create a new plugin or at least overwrite this one. Okay. Oh, another thing that I actually forgot to mention is this one. So the main problem is that we have lots of nodes here, and some of them are overlapping, so they are not that good to see. There is another library which is called the Colagraph, and the idea of Colagraph is to spread the nodes so that no node is overlapping. So you see everything here and there is no overlapping here. And if you have lots of data, it's going to take a little bit of time to generate this graph. But yeah, at least you don't have nodes that are overlapping. Okay, so let's move here. All right, so FutureWorks is open source. I'm going to release it on my GitHub page. As I said before, I didn't have time to finish. Probably I'm going to finish it maybe end of June or July. But you can fork it from GitHub and you can add your own plugin, or you can fix some bugs, because I'm sure there are. I want to add a timeline because at the moment I'm collecting the information from everywhere, and of course if some domains was malicious, I don't know, a year ago, I'm collecting that node. So you might have lots of false positives in your report. So another thing is to add a sort of a timeline, if there is, so you can say, okay, give me all the information about this specific domain from today, from yesterday to today, or something like that. So you can see only specific malicious domains or IPs or MD5s. I want to try to weight the intelligence based on the links that they have, the connections that they have, because if you can weight automatically, of course, if you can weight the intelligence that you collected, you can probably try to proactively protect your network. So let's say this node has a very high confidence that is malicious. So, okay, let's write a rule automatically on our firewall so we can block attacks. Or we can, let's say, if we are an incident responder, we can say, okay, this is very malicious, maybe we should look into it properly. I want to improve the graphic interface because at the moment, if you mess up with some nodes, you can go back. You just need to refresh the page. So all the nodes will go everywhere. And that's a very big issue I'm having. So if you're using it, make sure you don't make any error. And another interesting thing is to add an interactive map, so you can identify where the attacks came from, the IPs in a map, so you can provide a fancy map to the SOC analyst or the incident responder or anyone that is actually using it. I suppose that's it. So thank you very much for your time. If you have any question, I'm here or around, so any question?